it's recording now. Okay. So, section 10.2, we're going to talk about combinations. Now, yesterday we talked about permutations. Today we're going to talk about combinations, and here in just a minute we're going to compare the two. But a combination is when you're having a selection of objects, but it doesn't matter what order things are chosen in. It can be random. Okay? So if I say I need 2 students to help me come move a bookshelf, it doesn't matter if I say Hannah and Dylan or Dylan and Hannah. It doesn't matter which order I choose them. Does that make sense? So order does not matter because they don't have a specific job. I'm just choosing 2 at random. So that is a combination. Here is the mathematical formula for that. Our calculator does it for us. What are those exclamation points made from yesterday? Starts with an F. Factorial. So remember, like 5 factorial was 5 times 4 times 3 times 2 times 1. And like 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's that number times every number that comes after it all the way down to 1. And there's a button in our calculator that actually do that for us as well. And that's the exclamation point. So let's type in a combination. You type in a combination very much like you did a permutation yesterday. You turn on your calculator. I'm going to clear mine out. The number on the left is your total. So this one we have 5 objects in a combination, and we're choosing 2 of them. Okay, so your first number is your total. So hit the 5. Then you're going to hit the math button. Where is the math button? Under the alpha button. Then you're going to find the abbreviation for probability, and you can actually arrow backwards and highlight it. And then you find the one with the C. Which one has the C in it? 3. And then you hit your R button, which is how many you're choosing. We're choosing 2 on number 1 down there. So we hit 2 and hit enter. And that's how many ways we can choose 5 objects. I said that backwards. It's how many ways we can choose 2 objects out of 5 in a combination when it's random. So there's 10 ways to do that. So you would just say equals 10. Now these numbers are going to be smaller than when you have a permutation because of you're dividing by more in your denominator in the original formula. So like I said, I'm not making you do the formula. We're putting it in a calculator, moving on with our life. Okay? So y'all practice that one, then I'll practice it. 21C16. 21 items. We got a combination. We're choosing 16 of them. Type that in and see what number you get. I'm going to do it in my other calculator. What'd y'all get? 20,349. Did y'all all get that? Okay, good. All right, so now let's just see what it looks like in a problem. That's why I have typed all these out for you guys, is because they're word problems, and it just takes longer for y'all to copy from the screen than it really does to work the problem. So I'll just have them already ready to go. So a standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. We're going to talk more about cards in a minute. If the order dealt is not important, how many different 5-card hands are possible? So we don't even need that there's 4 suits and 13 different cards per suit right now. We just need the total and how many cards we're getting in a deal. Okay? How many cards we're getting dealt? People playing? No. You're getting dealt 5 cards. Okay? So how many total cards do we have? 52 divided by. It's not divided. All you have to do is there is your total, goes on the left. How many cards you're choosing goes on the right. Does that make sense? So you're going to type in 52C5 in your calculator. So the total goes on the left. How many you're choosing goes on the right. So you're finding how many ways you can get dealt 5 cards. So you type it in like that. Hit enter. How many?
2,800,500.
Say it again. 2 million. Yep. Card hands, I guess we would say.
Oh, that can be just changing one card in the whole hand.
Yeah.
Okay.
So there's that many possible hands you could get anytime you play cards if you have five cards.
You can think about it like there's 52 cards in the deck, and there's 4 suits.
Yes.
And then each number is the
Yeah, we're going to talk more about specific types of cards in just a minute.
You can break it down.
Yeah, because we're this is just section 10.2. In section 10.3, in just a minute, we're going to talk about probabilities of getting certain things. Not that good. All right, here's another combination example. Parents have 10 books that they can read to their children this week. How many different sets of 4 books can they choose? Okay, so it doesn't matter which order they do them in. They just have to choose 4 books. So that's why it's a combination, because it does not matter which order they're in. So how many is our total?
10.
How many are we choosing?
4.
4. So you're going to type in 10C4.
2 to 10.
210? Or I should say ways to choose. As I told y'all yesterday, word problems need word answers. Okay. So this is highlighted. I think it grayed out on your notes. I'm sorry. It says, when do you use a permutation and when do you use a combination? Okay? So, if it matters the order in which things are chosen, then it's a permutation. If order matters, it's a permutation. I always say if order is important, it's a permutation. Okay? If order is important, then that means it's a permutation. Also, placement. Like if I'm giving things a certain place, like seating around the table, we might think in my house it might just be you get a seat. It don't matter who sits where. But in some people's houses, Daddy sits in this one, Mama sits in this one, Brother sits over here, and say that's the way it's in my house. Davis gets to sit at the head of our table, but whatever. Because, like, back in, like, the olden days when everybody was very mannerly and stuff, we're not so mannerly anymore, then the head of the table was for the master of the house, right? The man of the house, I guess you would say. Yeah, that table right next to him on his right-hand side was his wife. But to the left of the head of the table was usually like a guest of honor of something. So if you're like fancy and not living in McNairy County, if you're putting people around a dinner table, then I guess order matters. Does that make sense? So if placement matters, it's a permutation. Also, if you're like choosing somebody for a specific job, that's also a permutation. Or if you're doing an order of first, second, or third place, like we did some yesterday, that's a permutation. Okay? But if the choosing can be random, then we use combination. Okay? So I'm going to give you a few examples here, and we're going to discuss whether it's a combination or a permutation. Okay? So if order matters, it's a permutation. If it does not matter, it's a combination. Okay. There are 25 students in a class. The class wants a president, secretary, and reporter. How many ways can 3 students be chosen for these jobs? Now, do y'all think that's going to be a combination or a permutation? Why?
Because it's not important what they choose.
No. Because if you're a president, you have a certain job. If you're a secretary, you have a certain job. And if you're a reporter, you have a certain job, right? Those are different roles. Does that make sense? So this would be a permutation. So you would do it 25P3. There's 25 total. It's a permutation because they have separate jobs and 3 of them are chosen. So you're going to type that in your calculator for me. 25p3. Hang on, you're ahead of me. 13,800. Let's say, I'll just say ways. So and that seems like a lot, doesn't it? In a classroom full of 25 students, 3 of them are chosen for a job. 13,800 ways we could choose. We don't have 25 students. Sorry.
Yeah.
Yeah, for real.
So 5p3.
That'd be a lot less, right?
5. Oh, what?
How many would that be?
60.
It's true, because you do that formula for permutations. All right, so y'all tell me if this one's a permutation or a combination. Remember, if the order or the placement or the listing matters, it's a permutation. If it can be random, it's a combination. Okay? There are 31 students in an algebra class. The teacher picks 4 students to help her carry textbooks to the library. How many ways can the students be chosen?
That is random.
It is random, right? So
You use the C.
I use combination. Very good. So 31C4. So y'all type that in. I think you're going to get a big number.
31,465.
I'm glad there's not 31 of us. 31,465 ways that the teacher can pick 4 students out of 31 to help her carry books to the library. Does that make sense? Y'all kind of see when it can be permutation, when it can be combination? Okay. If it can be random, it's combination. If it cannot be random, it's a permutation. All right, that's all of section 10.2. So now we're going to do section 10.3. And that is talking about probability. So probability is the likelihood an event will occur. How likely something is going to happen. So you need to know this formula for probability. Probability of parentheses, A is whatever the event name is the number of favorable outcomes over the total number of outcomes. So favorable is what you want to happen. Favorable means what you want to happen. Over the total possible outcomes. Okay? So we're going to roll a die. I have lots of dice, so let me find a 6-sided die for us. Cute. All right, so y'all know a die, if you have one of them, it's called a die. 2 are called dice, right? Y'all know that? Die, dice. I'm not telling anybody to die. Just one of them is a die, okay? All right, so if I have one die, how many numbers are on my die? How many numbers? 6. The numbers 1 through 6, right? So I've got a 1, 2, 3, 4, 5, 6, right? They're all numbered 1 through 6. What's the probability that I roll an even number?
3.
Well, how many even numbers are on a die? 3. That's my favorable. There's 3 even numbers on a die. How many total numbers are on a die?
6. You got
6. And then you reduce the fraction. Favorable over total, reduce it, you get a half.
And that reduces to 50%.
Well, we're going to leave them fractions. But yes, you have a 50% chance of rolling an even number. Okay. So the next thing they want is the probability that I do not roll a 4. So P not 4 means any number besides a 4. How many numbers on a die are not a 4?
5.
Well, everything except for 4. So there's 5 of them that are not 4, right? So that's 5 out of 6. And that will not reduce, so that's your answer. Does that make sense to everybody? Okay. So let's talk about cards. Y'all know what I'm talking about. Let's see if I got some. I got some. And bicycles are the best. Okay, so I've got a deck of cards here. Now, y'all need to write this stuff down because some people just don't know much about cards these days. Me and my daddy played cards all the time. And y'all just kiddos don't play cards as much as we did. This was before we had cell phones and before we had smartphones. And I couldn't just play Fortnite all the time. We played cards. All right? So, we didn't have any Snapchats or Facebooks or Instagrams or Twitters or nothing like that. We had to keep ourselves occupied in the dark ages. So me and my daddy play cards. And he's a lot better than I am at it. All right, so we got 4 suits, and there they are, the diamonds, the hearts, the spades, the clubs. And there's 13 cards per suit. So for the diamonds, you have an ace. Do you have a 1 card in the deck of cards? Is there a 1 card in the deck of cards? No, it's called an ace. They call it ace. So you got a 2, a 3, 4, 5, 6, 7, 8, 9, 10. And then you have a jack, a king. I need to put them in order. Queen and a king. Right? So for hearts, you have an ace, a 2, a 3. All right. And those are all red. The diamonds and the hearts are the red suits, right? So for your spades, you have a black ace, 2, 3, 4, 5, 7, 8. Yeah. And then jack, queen, king. And same thing for your clubs. You got an ace, a 2, 3, 4, 5, 7, 8, 9, 10, a jack, a queen, and a king. So those are all of your possible cards you have in a deck of cards.
13 times 4 is 52.
Yes.
What about the jack?
So there's 52 total. 4 suits. Those are your suits. Diamonds, hearts, spades, and clubs. 13 cards. These 2 are red. These 2 are black. Right? So we're going to find some probabilities. Now, if we're talking about decks of cards, how many is going to be our total? 52. So we want to find all these different probabilities. What's the probability that I draw an 8? Let's say we shuffle this deck really good and I let you draw a card. What's the probability that you get an 8? How many 8s are there? There's 4 of them. So 4 out of 52. And then we reduce the fraction. What is 4? 4 goes into 52. How many times? 13. So that reduces to 1 out of 13. Right? So we've got a 1 out of 13 shot of drawing an 8. Guess what? You got a 1 out of 13 shot to draw any kind of number or face count card, right? I got a 1 out of 13 shot of getting an ace. I got a 1 out of 13 shot of getting a king. Right? Okay. What's the probability that I draw out a red king? Well, how many red kings are in a deck of cards? 2 of them. So that's 2 out of 52. And what does that reduce to? Math inner is your friend. 1 out of 26. Very good. Yeah, I know you shouldn't use your calculator, but I'm just saying. All right. So what's the probability of getting a black face card? Now, what does it mean, face card? Y'all tell me what a face card means, though.
One that don't have a number on it.
That means it has a face on it, like a person with a face, right? So which ones have faces?
You have an 8% chance.
No, I don't want numbers. Ace don't have faces. Let me find an ace. Ace don't have a face.
But an ace is considered a face
It
card,
does
isn't
not have a face. Right? Here's a king. He has a face.
I mean, you got 6.
Right. So my black faces are the black, jack, king, and queen. Right? So how many black faces do I have? 6 black face cards out of how many total cards?
52.
52. And that reduces to what fraction?
3 over 26.
3 over 26. They're both divisible by 2. And then what's the probability, the last one, that we get an odd number card? Well, ace, kings, queens, and jacks are not numbers, right? So my odd number cards that are possible.
If it's not a number card, and it's not a face card.
Which is nice. It's special. All right. So odd numbers are 3, my 5s, 7s, and 9s. And there's 4 in every column, right? So 4 times 4 is, so there's 16 odd numbers on the cards out of what?
52.
Total cards. And I know I divide them both by 4, right? So 16 divided by 4 is 4. 52 divided by 4 is 13. So 4 out of 13. So there's a little card probability for you guys. You have a few on your homework card probability. All right. So next, we're choosing a number 1 through 20. So we're picking the numbers 1 through 20. What's the probability that we pick an even number?
1 out of 26. No. Okay.
So if we have a numbers 1 through 20, how many numbers are 1 through 20? 20 of them, right? So yeah, it's okay. So there's 20 total. How many of them are even? 10. And then that reduces to a half, right? Does that make sense? Okay. What's the probability that a number is a perfect square? Well, I just happen to have my squares written on my board over there. So how many numbers between 1 and 20 are perfect squares? Well, 20 would happen before here, right? So my perfect squares will be 1, 4, 9, and 16. So how many of them are there? 4 out of 20.
2 over 10.
They're both divisible by 4. So
Oh, yeah, 1 over 4.
1/5.
Yeah,
Are we okay with that? Okay. C wants the probability that we get a prime number. So let's list our prime numbers 1 through 20. 1's prime, right? 2's prime. What else prime? Is 3 prime? Is 3 prime? What does prime mean? That the only factors it has is 1 in itself. Okay? I'm going to listen. 1's prime, 2's prime, 3's prime. Is 4 prime?
No.
No. Is 5 prime?
Yes.
Is 6 prime?
No.
No. Is 7 prime?
Yes.
Is 8 prime?
No.
9 prime?
Yes.
Is 9 prime?
5.
3 times 3 is 9. Yeah. Okay. Is 10 prime?
No.
11.
Yeah.
12. 13.
Yeah.
Are any even numbers after 2 negative prime? No, because all even numbers are divisible by 2. Right? So we can skip those. Is 15 prime?
No.
No, 5 times 3. Is 17 prime?
Yes.
Yes. Is 19 prime?
Yeah. No.
Is 19 prime?
Yes.
Actually, yes.
No.
Nothing goes into 19 besides 19 and 1. All right. And then 20 is not prime. So 1, 2, 3, 4, 5, 6, 7, 8. Huh? 20 is not prime. That's what it says. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 numbers not prime out of 20. Or 9 numbers that are prime out of 20. So 9 out of 20, and that will not reduce. Okay? So, D wants the numbers out of 20 that's a multiple of 3. That means you can multiply times 3 and get something. Okay? So y'all can't buy 3s till we get to 20. 3, 6, 9, 15, 18, and then 21's bigger than 20, right? So how many numbers are multiples of 3? 6 out of 20, which reduces to what?
3 over 10.
3 over 10. So any questions about those? So you will have some like this on your practice today. All right, back of your notes. Experimental probability is something that we have taken an experiment on and we see what's happening. This could be results from like a poll or a voting thing that happened or a survey or something like that. So it's a number of trials where it happened over the total number of trials. So if it already has been an experiment or a vote or anything like that, it's the number of times it happened over the total. Probability is always over the total. So it said to look at page 400. And I need you to look at page 400 because I'm not drawing that picture. Go ahead and get your book out because you're going to need it for homework anyway. So we're just going to go over it out loud together. Page 400. We're obviously not on page 400. That should say, look on page 700, not 400. Mark that out on your paper. Look on page 700. My bad. I'm like, 400 should be bigger than that. So mark that out on your notes. I apologize. So notice that we have a survey that we've taken and they give you a bar graph. Do y'all see that? Okay. It said the bar graph shows how old adults in a survey would be chosen if they would choose any age. How old people would choose to be if they could choose any age. Okay, that makes more sense. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. So we need how many chose to be at least 40 out of the total. Okay? So how will we get the total?
Add all numbers.
And they told you above the bar how many are each bar, right? So you would add 463 plus 1,085 plus 879 plus 551 plus 300 plus 238. And they got the total number to be 3516. That's their total. Y'all see how they got the total? Then they said, of those, how many chose to be 40 or older? So which bars are you looking at? The last three. So they add 551 plus 300 plus 238. And they got 1,089. They simplified that to a decimal to get the probability. And they got 0.310.
So 31%.
Yeah, so about 31% chose to be 40 or older. So almost a third. I would not choose to be older than 40 because 33 hurts. I have places that give me aches and pains already. I would not want to be 40. Y'all see me. Y'all come visit me when I'm 40 and I'll be riding around on a scooter with Mr. Don. All right. So that's the end of section 10.2 and 10.3. Have a good day.